we'll just start, you know.
Okay.
Look at me, forget the cameras here, all that fun stuff. Cool. So we're here with the networking team, right? And who are you, and what happened to your office?
Oh, well, I was on vacation, and some of my colleagues and friends thought they should color up my office a little bit.
Yeah, a little pink.
I've cleaned up a whole lot, but still, you know, you can look at the light.
He likes it that way.
Tell the truth. That's why it's not clean yet.
So. Actually, yeah, go on.
So the reason I wanted to come over and talk to you guys is I heard there's a new networking stack in Windows Vista, right? Completely, so you've been busy. That's why you blow off a little steam. You've probably been pulling too many all-nighters lately, getting ready for Beta 2. So what's new? And why rewrite the networking stack? Didn't the old one work fine?
Well, the old one, I mean, we had improved.
And who are you, first of all?
Abolade. I work on transport, so TCP, you know, all of the. Well, actually, I work all over the stack. So I mean, we're getting to the point where adding new things is getting harder and harder because we think, oh, we should really do it this way. Yeah. But you know, going and changing in the old code was getting more and more of a challenge, you know, without breaking app compat. So a few years ago, we just started thinking about how we would redesign things from the ground up if we had the freedom, you know, to start over. And the designs for that, you know, and discussions, you know, throughout like the networking team ended up, you know, being the basis for changing the entire stack for Windows.
Wow. Now, what does it give my mom?
Well, what does it give your mom? A whole lot, actually. So it ranges from, you know, like the security things that we've put in. You know, so like, for instance, the firewall is much better integrated, so you can do things like control which applications are allowed to use the network at a much finer granularity. There's a lot more attack resilience, so if your machine is getting attacked, it holds up much better. There's things like the performance is just phenomenal. I mean, we can show you some of that. Like
and there is a host firewall as well. Yeah. There's a host firewall as well. Wow. So this is an extension of what was there in Windows XP Service Pack 2. Yeah. This is a lot more secure and definitely helps your mom not get infected by all those malicious worms out there.
Yeah.
And we have a more driver model also in the sex.
What driver?
A better and new driver model for the
and who are
drivers.
You?
I'm Ali. I'm working on NDIS driver, and so that's another part that we improved performance and also reliability in the stack.
Wow. Now, I heard that you guys, one of the big goals was to get into IPv6, right?
Absolutely.
And what is that?
So IPv6 is the next generation internet protocol. We actually had basic support for it. That was an add-on onto XP and Win2K3, but you basically had to add another driver to the system. It wasn't really integrated as well, so now we have ground-up support for it. So
and what's cool about IPv6?
Well, what's cool about IPv6 is you have so much more address space, and there are things that are much easier to do. It's kind of like the switch from 32-bit computing to 64-bit computing. Yeah. So many things become so much easier with IPv6. The way the security is built in, new scenarios, you know, peer-to-peer.
What it really lets you have is a lot more IP addresses, right, for address. Because each computer on the internet has an IP address.
Yeah.
But a lot of them are sort of fake IP addresses, right?
Exactly.
Like behind my NAT, I have one IP address, but it's being split up into 3 or 4 computers, right?
Yeah, exactly.
And there's entire countries that are splitting up like a handful of IP addresses. And that's sort of unfair to some of these countries, right?
Yeah. So there's just, you know, the address space, but then when you have...
I heard MIT has more addresses than several countries
like
put together.
Exactly. And when you have more addresses, you can start to do things like have whole networks, you know, that can move around. I mean, there are features that you can enable that are much easier to do with a bigger address space. Same thing with, you know, 64-bit computing.
Very cool.
So
where do we start?
There's so many places to start.
Now, you had some demos to show us some of the new Windows Vista networking features?
Yeah, so
let me make sure I can see this. Yep, cool.
So the first thing is you asked Abolade, we have both IPv4 and IPv6 enabled stack, right?
Yeah.
So from now on, if you just go to a long-hardened machine and do an IP config, you see a lot more addresses, a lot more adapters. So if you see these long literals here, they are IPv6 addresses of various different types. Wow. So these are all enabled by default on Vista.
Okay.
So these we believe are going to help people do peer-to-peer networking with a lot more ease, and applications will be able to traverse through firewalls and NATs, not having to go through the trouble that v4 applications went through.
Very cool.
So we also have developed, basically we have developed several new technologies in.
Sorry for your pink face. It's your lights. You can blame your coworkers for that.
Well, I've left it out aloud for them, So, we basically have taken a holistic approach in Longhorn. We want it to be the best network operating system, both for.
Let me turn around so I can get
Sure.
some of the light on.
Sure.
There you go.
So.
Otherwise, I couldn't see your face.
So with Longhorn, what we have done is we've taken a holistic approach.
Yep.
We want it to be the best network operating system for both workstations as well as for servers. In the past couple of years, we have gathered requirements from customers. Like one of the big concerns that we had to address in Longhorn was that a lot of routine network operations, such as TCP data transfers, a bulk portion of it,
Yep.
is all mundane routine operations there is not a whole lot of intelligence built into the data movement part of it. But it takes up a lot of CPU cycles, which are more and more expensive. So what we did in Longhorn is we came up with a new offload architecture,
Yep.
where we offload a certain segment of this mundane routine operations, which require less intelligence but a whole lot of CPU cycles,
Got it.
to specific network processors which are going to be shipping with the network interface cards that you buy. They will be shipping with a slightly higher price, but nothing compared to the hundreds of dollars that you pay for a Pentium CPU.
Yep.
So that is one of the cool new things where we are innovating, and we hope that this is going to revolutionize the way servers work. It's going to basically bring down the price point so much that Windows and our hardware partners who are working with us in building these technologies, I think.
So what kinds of things, does that mean something for the home or more for the
This is
data
more
center?
for the servers.
Okay.
This is more for servers. And given that the price point is so much lower, we believe that this will go on all desktop computers as well, and pretty much every Windows customer will benefit from this.
Interesting.
The
So
other,
this network stack is going to be in the server version of Longhorn as well as the client version of Windows Vista, right?
yes, it's the same network stack that's going to be
Okay.
on all flavors. The other cool thing that we have done is receive side scaling, and Ali is going to talk more about it.
Yeah.
Yeah, so receive side scaling is all about taking advantage of all the CPUs in the.
Look at me.
Yeah.
the camera.
Okay. So receive side scaling is all about taking advantage of all the CPUs and scaling up to the number of CPUs that you have in your machine. Today, when your NIC driver receives a packet, it always ends up just taking advantage of one CPU, processing them on one CPU all the time.
Really?
So no matter, yes.
I
So
didn't know
for
that.
one NIC driver, doesn't matter how many CPUs you have in the system, it might be using all the CPUs, but it will be using them in a serial fashion. It will be using CPU A for one packet, and then once it's done, it will shift to CPU, the other CPU, and then use it for this next packet, etc. So it will not be using all the CPUs at the same time and concurrently. So the receive side scaling is all about classifying the packets as they arrive, finding the right CPUs for them to be processed on, and queuing them on that CPU and processing them on that CPU. So we can take advantage of the multi-proc machines.
Which there's going to be a lot of in the future,
Yeah.
right? Intel's coming out with,
Correct.
they're printing out multi-core processors.
Exactly.
Multi-threaded, yeah.
Yeah.
So
Exactly.
actually, even my desktop machines,
Yeah.
they are by default multi-threaded.
Yeah.
So Intel is just making multi-threaded CPUs all the time. So, and going forward, they're
And
doing
AMD
multi-core.
too. So.
Right.
So
Intel's not the only company down
When you
south
start
there.
going to media playing, streaming media in the home, this is going to be important because it makes it much easier to achieve glitch-free playback. And glitch-free is another place where we're trying to do a lot more work, trying to get to the point where the CPU load on the machine itself is less of a determining factor in how smoothly your media plays back.
Yeah, that's another area that I want to talk. That on the client side, we're trying to make sure that the network traffic and processing network traffic does not affect and degrade the multimedia playback that you may be having running. So in glitch-free, we make sure that all the application in your system take the fair share of the CPU cycles. So something like a heavy network traffic does not end up causing glitches in your video or audio playback.
Wow. what other things would now? Do I need to learn anything
Under
as
the
an
hood,
end user?
under the hood, a lot.
Right.
Okay.
So what? Yeah, like
You
this
need
is
to know
like
even less than you
exactly.
did
That's what I was gonna say. So in the previous versions of Windows, people would say, "Hey, here is my application, which is going to change 30 registry keys on your machine, and your network is going to run a lot faster." And to be perfectly honest, some of them were necessary, but a lot of them were not necessary and incorrect. But in Longhorn, we have made a conscious effort to get rid of as many registry keys as possible. We've gotten rid of most of them. So one word of caution for a lot of people is those tools probably will not work as they did
But you
with
won't
the
need
old
them.
stack.
But
Right.
you won't need
But the
them.
best-
That's the key
right.
thing.
But the best part is you will not be needing them.
Yeah.
So we have tried to build all that intelligence into the stack already in such a way that it adapts to networks from gigabit speeds to wireless speeds, from high latency to low latency. So that's I can show you one of the demo that probably will help you appreciate one of the innovative algorithms that we have built in the Vista TCP/IP stack.
Okay.
At the core of the internet data transfer mechanism is TCP, which is the transmission control protocol, right? So this accounts for more than 90% of the internet traffic. And one of the problems with the TCP is its age-old congestion control algorithm, which was invented more than 15 years ago. So that was designed for networks that were of very small, very low speeds, and people were happy to get their data across on the network. Now things have come much further along, and we have, in working with the Microsoft research, we have come up with a new TCP congestion control algorithm. Okay. This is called CTCP or compound TCP. Okay. This is going to be shipping with in Vista as the default congestion control algorithm.
Okay.
So if you look at, this is a tool that shows the basically this is a tool that we built just to help us analyze various different things with TCP and also demonstrate how the new and the old congestion control algorithms behave. Okay. So this basically is showing this is analyzing a current data transfer. Okay. So this test, what this did was it transferred to the same file twice. Once over the conventional congestion control algorithm that we had in the previous stacks. This is called the Neurino congestion control algorithm. Yeah. And this is something that takes a long time when there are even small number of losses in the network. Okay. So this basically reduces the effective throughput customers can get over high bandwidth latency links. Okay. So if you look at this graph that you're seeing here, after so this basically denotes a drop in the a drop of a packet. So every time there is a packet drop, the ramp up that you see is very slow. So every time there is a drop, it comes back here and the throughput gradually increases. Yep. So this basically results in less effective throughput. Yep. So now let me show you so this is the conventional algorithm. Now let's choose a graph that we had with CTCP. This is something that we got by implementing the congestion control algorithm that Microsoft Asia has implemented. Yep. Actually, they were the ones who invented this. So if you look at what happens here, if there is a loss, it doesn't try to go back linearly like it did with Neurino. It tries to go back up immediately, but if there is another loss, it drops back. But again, it tries to go back up. It doesn't do the linear increase. Yeah. Why this is not going to cause any other problems to the rest of the traffic or to the internet is that it uses delay in the round trip times, the change of round trip times as a way to figure out how much data it can put on the network. Whereas the Neurino scheme does not care about the delay as much. So it responds to packet losses, whereas the new congestion control algorithm that we have is going to respond to delay.
Sorry about that.
Delay based.
Let me get on that side of you because the lighting is a lot better.
Sure.
Thanks.
So our new algorithm is going to respond to variations in delay as well. Wow. So how is this going to benefit the end user? Right?
Well, you pay more for a DSL connection that's faster. You will immediately see benefits with Vista. In fact, we actually have
on the same machine. So if I go home right now and I load beta 1, is it in beta 1 or beta 2?
This is in beta 2.
Beta 2.
Beta 2. So if I load up beta 2 when it comes out, I'll see an immediate speed improvement.
Absolutely.
And you might be frightened by the amount of speed improvement that you see. On some links, for instance, we have at Microsoft.com has been doing some testing, and they have this link between between Seattle and
Bay Area.
the Bay
San
Area,
Francisco. Yeah.
and they saw an improvement of it was a 40x improvement that they saw on that link in terms of throughput that they were getting. So they,
now, do you guys have to do anything on a server? So if I'm running a Linux server or a Windows NT box,
so long as the machine that's doing the download is running Vista, you'll see dramatic improvements. Now, if they're both Vista machines, if the server and the client are both Vista machines, and the server has some of the intelligence that we've built onto the sending side, then it will be even better in recovering from losses.
So if they use Longhorn for both sender and receiver, it will be the best.
I mean, basically, what we were aiming for is to be the state of the art in using the network and network transfers in security and throughput across the board, and we think we're close.
Right.
We're not
We are
there
close.
yet.
We are close.
Another feature that I'd like to talk about is it's not as sexy as some of the features that you
I'm
mentioned.
still blown away. I'm going to go home right now.
You bet.
So for Vista, we came up with a new driver model, which makes it possible for our partners, network vendors, to write drivers for network devices a lot easier and more reliable and get a lot more performance. Part of the performance improvement in Windows Vista owes it to the some of innovation that we did in the entire stack, using the new data structures to pass the data, making sure that always we pass a chain of data structures instead of one packet at a time, so it makes the CPU utilization go down and performance throughput to go up. Another innovation that we did in Vista networking that I'd like to talk about is lightweight filter driver model. That makes it very easy to write firewall drivers and or a lot of other applications that for whatever reason to need to look at the network traffic. It makes it possible to dynamically add them and remove them without tearing down the connection. And it makes it a lot more reliable than the current way that the firewall drivers are operating. Unfortunately, in many cases, current firewall drivers have to go and hook internal routines and data structures in the stack and make the entire system very unreliable and very fragile. So the new lightweight filter driver model allows this firewall to be written in a way that without any substantial performance degradation, they can be added to the system, and at the same time the reliability of the system won't suffer.
Will you need to buy new hardware for the new?
No, you do not need any special hardware for using lightweight filter drivers.
Very cool. What else about networking do we need to know? You talked a little bit about IPsec. What's going on in there? What is IPsec, anyways?
Well, IPsec. Go on.
IPsec is basically the security protocol that allows us to protect, a lot of the traffic that's exchanged between clients and servers, or just between pairs of machines. Okay. So, especially in the domain environment, the work that we're doing in Vista is going to make it really, really compelling, to start using IPsec. So we already have a pilot inside NTDev where we have this IPsec rollout, which allows us to say that, for instance, my desktop machine will only talk to other machines that are also part of the domain. So if some bad person comes, into one of our buildings and plugs in a computer to one of our Ethernet jacks, it doesn't matter because they won't be able to talk to any of our machines because all of our machines require IPsec. So that's what we kind of call like a domain isolation model. It protects machines that are part of the same domain.
Okay.
And then there's another thing that we're working on, which is more for the future, which is the notion of authenticated firewalls. The idea there is that you can use IPsec, the capabilities that I just talked about, to say, for instance, on your home machine, I don't want to talk to anybody unless, say, they're on my buddy list in MSN Messenger. So now your machine is starting to protect itself when it's on the open internet from all kinds of attacks. And it's
so
the same
it's sort of a pseudo domain at home?
You can kind of think of, well, it's more than a domain, because what it means is that you know exactly who your machine can talk to at any given time. So like when there's a worm spreading, like you're immune because you set it up so that, okay, folks who are in my family can
Unless
talk to
your
me.
buddy is also sending you the work.
Yeah, but it scopes
I
down
got some wormy buddies.
But you know
it
you
scopes
know where
down the
to
problem
point
a
your
whole lot. It
fingers
gives you
to.
more control, over what your machine is doing. Right now, you feel like, you don't really have control. Like, who's sending me
That's
packets,
true.
who's making connections, usually my file shares. So IPsec is a big part of how we're going to, make that much better for people.
Let me just move my tripod a little bit here. One new scenario that we all deal with now is going to Starbucks, right? And
Yeah.
using Wi-Fi.
Mhm.
And some kid can be sitting right next to you and
Yep.
sniffing every bit of traffic
Yeah.
that you're sending over the open Wi-Fi network.
Yeah.
Do you guys have any new protections for Wi-Fi? Or?
Well, IPsec helps a lot there as well, because
Okay.
if you require, that anyone who sends you packets uses IPsec. IPsec has two parts. You can authenticate the people who are communicating with you to make sure they're who they say they are. You can also secure your traffic. So one of the things that we've done is we've made it really easy for developers to write applications that by default are secure out of the box. So we have this secure sockets API. So when you're writing an application that needs to transfer data over the network, by just setting a socket option, in the application, you can enable security, encryption as well as authentication for that traffic. Just, we just try to make it as easy as possible.
Wireless team is a separate team, but they have done great things in improving the security of wireless communication. Not only they have developed new security methods like WPA2, they have also made it possible for many third-party security providers to plug into the stack and add their own decryption model.
Interesting. Do you guys work with the phishing team at all? In terms of detecting whether an email coming through is actually from your bank and not from some...
Not really.
Yeah, I'm going to interview with that team, so I just wondered if you were working with them to help give them some more data that they can use.
Yeah, some of
We're sort of the low-level people.
Yeah, some
Yeah.
of the work we've done.
You're the plumbing under the street, and they're
Yeah,
working at the housing levels. Okay.
Yeah, but I mean, our goal is to start pushing things up so that it's harder and harder to attack the lower levels of the stack. So now you have to start going after, human behavior to be able to get into people's systems. Like if we can push things to that point, then we consider,
You're talking about
quite
the
a
computer,
success.
your computer slapping you if you try to wrong.
Yeah.
That would be nice.
No, the interviewer slapping you.
Yeah.
Anything else that, as an end user, would I know? Where would I see? You told me performance. I'll see it.
Yeah.
Is there any other place that I'll notice your work?
It'll
Because
it'll
if you guys did your
more
work
secure.
right,
Right,
you should notice.
we'll never know you did any work.
Exactly.
Right?
That's the point, right? I mean, file system. Think of file system, right? I mean, I have really not come across users who care about, oh, let me tune my file system, right? I mean, yeah, there are some defragmentation tools and such, but I mean,
It doesn't kick in automatically, right?
Yeah.
So it's kind of, we want networking to be at that stage, right?
Yeah.
People should take networking for granted. That's it. They should know, like, it's secure, it's safe, it gives the best performance that we can get out of it, and I'm going to stay away from it and just use it. That's pretty much where we
Yeah,
want to get to.
in short, we like to take work out of the networking.
Mhm.
Very cool.
That's a cool
you mentioned some developer now. So for end users, we're just going to see better performance and better security. For developers, what's new there that we'll need to worry about?
Oh,
Where do we
a lot
begin?
there, actually. This is the part that probably your mom wouldn't care about, but there's a lot for developers. At least starting with lowest layer, which is the network drivers. The set of interface that the network manufacturers have now to write the drivers for the next network interface adapters is a lot more streamlined, a lot more efficient, and very well documented. We pretty much redesigned the entire API interface that we had for the developers for network drivers. And I let Sanjay and Abolade comment about the improvement that we have made in other areas.
So one of the other APIs that we have improved drastically is what was called as TDI, or the transport driver interface. Developers have complained about its complexity and its lack of performance
And features. Lack of features too. There were a lot of stuff that they wanted to do that they could not do with TDI.
Yeah.
Right. So one of the things
What does TDI do? Where would I use that as a developer?
If you were writing an application that uses networking in the kernel, basically in the past your only choice is to use the TDI interface to create your sockets, to set up connections and do data transfer.
Okay.
So what Abolade has done is come up with a new interface called TLNPI, but it is somewhat of an abstract interface, and the public interface, which is a replacement for TDI, is called the WinSock kernel. Since a lot of developers are familiar with WinSock in the user mode, the idea is to bring it down to kernel so they can use the same socket semantics and programming paradigms so that they can write programs with the similar ease in kernel mode also.
Yep.
So this is one of the biggest steps going forward, is what I feel.
It's a pretty dramatic improvement, because when you look at at the amount of code you have to write to use TDI for setting up a connection and just exchanging some data, and compare it to the amount of code you have to write with WinSock kernel, we're talking about thousands of lines compared to hundreds of lines.
Okay.
So it's dramatically simpler, and there are fewer opportunities to get things wrong. We try as much as possible to pick the right defaults for people. So it's just simpler, and it means that machines will be more stable because components that are using networking in the kernel are simpler to write, and so it's just better for everyone.
Yeah. You guys live in the kernel mode, right?
Most of it.
Yeah, a lot of
Some of the tools that I showed you, these and the utilities, for instance, netstat, ipconfig, these are the tools that show the state of the network. They live in user mode, and some of our APIs are in user mode too, right? Mm-hmm. But the APIs in the user mode, they are largely owned by other teams which build on top of us. We don't really own those APIs ourselves.
Yeah. So another thing that's really important for developers is that we've done a lot of work to make the stack as transparent as possible. So trying to figure out what's going on with the connection, for instance, we keep detailed statistics. The tool that Sanjay showed you is actually built on top of statistics that we've added to TCP that you can enable on a per connection basis. So we can track, what the round trip time is, how long your path is, how much bandwidth we have available. Fairly sophisticated stuff on a per connection basis, and it's there out of the box for developers to play with, like right now. In fact, a lot of it is in beta 1. We're adding even more in beta 2, and we've designed it in such a way that even though we're keeping these complicated statistics, it doesn't affect the performance of the connections who aren't using it.
Okay.
So that's a big step forward. In addition to that, we also added a lot of tracing capabilities, so that if you're writing an application that uses a network and something doesn't work the way you expect it to, you can just click a button, in the diagnostics console and turn on tracing for TCP/IP, and that'll give you basically a narrative of exactly what the stack is doing and why, which components it's talking to, how it's handling requests, if something failed, why did it fail in the stack, and so on.
Right.
So that's for developers.
And then for diagnostic, do you want to talk about the diagnostic features?
I was about to talk about that. So now for users, we've done a lot of building on some of the same framework, some of the same foundation. We've also plugged into the diagnostics framework for networking, which is new in Windows Vista. So what this is going to do is that the common problems that users have with networking, the system will be able to diagnose them automatically and give them solutions. So, you're not able to reach a website. Well, why is it? Is it because, you can't, the name isn't resolving? Is it because, some router is down along the path? If so, is there something you can do to solve the problem? Yeah. The system is going to start figuring out this stuff for users and, diagnosing those problems, both when they're talking to the internet and when they're trying to get home networking scenarios working. Yeah. Which we think is going to be a huge improvement.
Yeah. Another thing that I want to make sure we get across is the extensive and seamless support for IPv6 that we have in all our APIs. Yeah. In the previous Windows releases, it was sort of fragmented. Not every API was available for v4 was available for v6 too. But in Longhorn or Vista.
Yeah.
So
you're gonna put a quarter in your shot.
Right. It's maybe 99% it's there. So there is everything. Like even the behaviors were different because we had taken the dual stack approach in the previous versions. Here it's the same stack with the same TCP and same transport sitting on two network layers. So the behavior of TCP is going to be almost exactly identical. Feature sets are almost exactly identical. Security, reliability, it's the same across the two platforms, and we hope this is going to encourage more developers to develop applications for IPv6, as well as users to use more IPv6 and capabilities.
It's really exciting. My son lives 1,000 miles away, right? And I'm using MSN Messenger and Skype and all sorts of fun. We just bought a new voice over IP app, Teleo, right? What are you guys doing for quality of service? Because right now, if you use Skype or one of these voice over IP things, sometimes you get a connection that sounds like it's a telephone, and sometimes it just doesn't work very well, and it doesn't tell you why it's not working, and sometimes you reconnect and it works great. What's Vista going to do for some of these new kinds of applications that are using video and audio? And
even in the previous versions of Windows, we had a fairly sophisticated level of quality of service APIs and infrastructure that's built in. We had scheduling components, we had marking components, we had reservation components. The applications can invoke these through APIs that are available at the socket layer. But the problem with a lot of these is that, say, the operating system says, hey, look, this is an important packet that you should give this a high priority queue, and you should put it in a higher priority queue in your router buffers, and you should ensure that there is as little latency on this as possible. But the problem today is routers do not strictly enforce or guarantee these reservations, or they do not honor these markings, because we don't really have the sophisticated SLA or the agreement between the host that says mark this and the routers along the way that reaches your son. Every router should look at this and say, hey, look, this is an important packet. This should get less delay than another file transfer packet, for instance. Until this happens, it's not going to be easy to guarantee end-to-end high quality of service. But on the other hand, what Vista does is, I believe in its Media Center edition, they have something called Q-Wave. So this basically helps home users get high quality audio video from their Windows servers or Windows Media Center machines to their TV, for instance, or to their speakers, for instance.
But that's in the house itself.
That's within the house.
Yeah, because I'm going to be having a Windows Media Center upstairs, and it's going to send video downstairs trying to extend her kind of thing.
And the file transfer your daughter is doing from her room with her friend, or the music download that she's doing, hopefully legal music download she's doing, will not interfere with the streaming that you are doing.
Very cool. What else do I need to know about networking? Networking is something we all take for granted.
I know, that's exactly what you want to be.
Except when it doesn't work. When you're at Starbucks and you can't connect to the Wi-Fi, we're all swearing at you guys.
What are these guys doing?
What do they do? What do they do to me?
I mean, if you still run into such issues, it is all Ali's fault.
Blame Ali.
we are perfect.
Yeah.
Those drivers, man.
You were talking to me in the other room about RSS, and what do you guys see in terms of what you could do for RSS?
Oh, RSS is not the
real simple communication.
Yeah, that's not what.
Unfortunate conflict of acronyms.
Oh, you have a different.
RSS is receive side scaling.
But actually, we are the ones who coined that phrase. Actually, Ali and Jim, I believe, were the two people who coined it.
That was 3 or 4 years ago. That was before RSS became.
Okay, this is let's.
Now you got Dave Weiner who's going to hunt you down.
So
what is your RSS and how is that different
from scaling? Receive side scaling.
Basically, it lets you make servers run faster and and take advantage of fatter pipes just by adding CPUs.
Right. So today, even if you add, so what happens is, let's assume you are running a server which is doing a lot of, say for instance, a file server where a lot of people are writing files, right? Yeah. So it is receiving a lot of data. Let's assume that it's driving a fat pipe, like a couple of gigabit pipes, right? Multi-gigabit pipe. So what happens is, say you have a 3 gigahertz CPU, several such CPUs, right? What happens is the way the networking stack and some of the other operating system components are architected, all the all the processing that needs to happen to basically take this data and put it in its place, it can happen on only one CPU at any given time. So even if for instance, since this is a CPU intensive operation, if you're getting a lot of inbound data, your CPU is going to get utilized and it's going to say run to 100% capacity, right? So what would a user want to do? He would want to add another CPU so that he can do more processing. But the problem is, because of the limitations that I referred to in the networking stack and related components, even if you add more CPU power in the form of another CPU, it will not even be utilized. So for one example is when the blaster attack hit Microsoft.com website, they were running 4 processor machines. Yeah. What happened was all the packets were coming in on one CPU, and only processor 0 was at 100%, while the others were at 0%. So what we are trying to do, obviously our IT people are upset, right? Hey, look, I have put money to buy these 4P machines, and your stack is not making use of the other CPUs. So what the NDIS and the transports team has done is to come up with this technology called receive side scaling, where the packets are split in the form of streams which go to different CPUs, and all the CPU that's available is used in an efficient way. So this, we believe, is we are not aware of any other operating system that does this, and we believe this is going to take servers.
Even that company down in Mountain View that it starts with a G.
No. The key thing behind this is that this allows us to get to 10 gigabit speeds, because when you actually want to drive a 10 gigabit pipe, if you actually do the math, the number of cycles you have available for each packet that would be coming in at the 10 gigabit speed, you just don't have enough cycles on today's processor.
If you have only one CPU.
Exactly, if you have only one CPU. Right. So now by adding CPUs, we can actually drive these fat pipes, which makes a huge difference for how fast you can deploy this new gigabit, 10 gigabit Ethernet technology.
Very cool. I can see all sorts of businesses that'll open up now.
Yeah. So actually, we have had a lot of the things that we have done here, like the congestion control algorithm that I just gave you a glimpse of, and the receive side scaling that we talked about, and the offload technologies that we referred to. All these we are working in very close cooperation with MSIT and Microsoft.com. They are excited, totally excited about what we're doing. Yeah. I can show you emails. Actually, if you come over here, this is an email that's sent by one of our Chris Saint-Amand, who is our IT engineer at the Microsoft.com site. I mean, he's like, just this is what we want to hear from people who use Windows, basically. Yeah. He is so excited. We are excited, and I'm very sure our customers are going to be excited as well.
Now, this is real interesting because a lot of the future growth in networking is going to be streaming out video, And I know the IPTV team is thinking about how to work with Comcast to stream out, IP-based video, not over-the-air video, but over the internet. This will let them build a data center that runs a lot more
Absolutely.
effectively.
I mean, you can, for instance, right? Everywhere you see, people are moving towards moving everything to IP. That's one, right? You talk to your son, not over your...
Oh yeah, even Boeing, when I was in the Boeing plane, they had a page with 4 videos.
Exactly.
So you could watch in the plane, and it's IP video. It's not direct TV or anything.
And people are moving towards geographically separated data centers, and there will be, there will be even more and more demand for data movement and storage technologies, and one of the first pieces that we need to get right towards this to get there is the networking stack, and that's what we hope to achieve with Longhorn.
Very cool. Anything else you guys want to talk about? I think we've covered the waterfront of what your team is doing.
Right, and we are actually very happy and excited and proud of.
Actually, maybe
now, who's this guy?
Yeah, we do our jobs right.
So assuming actually you can edit it later on to add it to the what we are doing for developers. Sandy, don't go anywhere, okay?
Well, we're almost done. So.
Yeah,
don't be camera shy, man.
We have improved our test tools a lot, So our developers have a lot more advanced test tools to test the drivers at the TLN and PI drivers, or the chimney offload capable drivers or NIC drivers. And so they can have a lot more confidence when they submit a driver for logo certification or give it to the customer to run it on their system.
Now, who was that that just walked by the way?
That was one of our champions for developing test tools.
Test lead.
Yes.
What's his name?
Sandeep.
Sandeep. Okay. So he's your test lead. He's doing testing.
Right.
Very cool. Well, thank you for spending some time with us.
Thanks for helping us get our message to our customers and developers.
Yep.
There's the PM.
Oh, there's your PM. He gets all the credit, right?
Well, we didn't even
I get all the bashing. I get all the bashing.
He gets all the bashing.
He has helped us put
He gets all the hate
together
mail. When I'm sending hate mail from Starbucks, I can't get on my network. Yeah.
We'll give you this earlier.
No,
phone number, cell phone number. Cell phone number too.
Well, thanks for spending some time.
Thank you.
Thanks for coming.